Simplify 3x squared times 5x to the 4, that's 15x to the power of 6. Simplify 12x to the 7 over 4x cubed, that's 3x to the power of 4. 2x cubed, all to the power of 4, that's 16x to the 12. 3a squared b, all times 4a cubed b to the 5, that's 12a to the 5 b to the 6. 2x squared all cubed, all over 4x to the 5. We cube the numerator to get 8x to the 6, and then divided by the denominator to get 2x just by itself. Then expanding brackets, expand and simplify x add 3 all times, x take 7, that's x squared minus 4x minus 21. 2x take 5 all squared, that's 4x squared minus 20x plus 25. 3x add 1 times 2x take 3, that's 6x squared, add 7x take 3. Then comes 3x times 2x take 4, all take away 2 times x squared take 5. So we get 4x squared minus 12x plus 10. And then x add 2 times x take 2 times x add 1. Expand the first pair of brackets, that should be x squared take 4, and then multiply that by x add 1, but in descending powers of x. Okay, so that should be x cubed add x squared, take 4x rather, and then take away 4. Okay, then comes factorizing. Factorize x squared, take 9x at 20. So that should be x minus 4 times x minus 5. Hello. Then factorize fully. 9x squared take 49. 3x add 7 times 3x take 7. Then 6x squared add 11x take 10. That should be, let's think now. Okay, so I think it's 3x take 2 times 2x add 5. Okay, and then 2x cubed take 18x. If we pull out 2x, then inside the bracket should be x squared take 9. So 2x times x add 3 times x take 3. And then we have to factorize x cubed, add 2x squared, take 15x. We pull out x, and then it just becomes a quadratic, so x times x add 5 times x take 3. Now, negative and fractional indices. So evaluate 16 to the power of 3 over 4. That should be 2 to the power of 3, which is 8. 27 to the negative 2/3. That should be 3 squared, which is 9, and then reciprocal of that, which is 1 over 9. 8 over 125 to the negative 1/3. That should be 5 over 2. Write 5 over root x in the form kx to the n. That should be 5x to the negative half. Solve 3 over 2 equals 27. That should just be 9. Simplify root 75. That should be 5 root 3. Then comes root 48, take root 12. Root 48 is 2 root 12, so it becomes just root 12, which is 2 root 3. Simplify root 8 times root 6, that's root 48, which is, well, it's 2 root 12, which is itself 2 root 3, so it's 4 root 3. Now expand and simplify 3 add root 5 all times 2 take root 5. Okay, that should be 1 minus root 5. Now, square 2 root 3, take away 1. I think it's 13 minus 4 root 3. Now rationalizing denominators. Rationalize the denominator of 3 times the top and bottom by root 3, so we just get 6 root 3 over 3, which is 2 root 3. 4 all over 2 take root 2 times the top and bottom by 2 plus root 2. So we get 2 on the denominator, and then that should cancel with the 4, so we get 2 times 2 plus root 2, so 4 plus 2 root 2. Now try 1 all over root 5 take 2. That should be root 5 plus 2. Root 5 plus 2. Now try root 3 all over root 3 plus 1. We're going to times the top and the bottom by root 3 minus 1. And if we do that on the bottom, that should be 2. And if we do it on the top, that should be 3 minus root 3. So 3 minus root 3 over 2. 3 minus root 3 all over 2. And last, 10 all over 3 plus root 2. 10 all over 3 plus root 2. So we're going to times the top and the bottom by 3 minus root 2. And if we do it on the bottom, we should get 7. And on the top, we should get 30 plus 10. All right. We're going to move on to chapter 2 now. Let's see. Here's chapter 2. Okay. We're going to solve these quadratic equations by factorization. First is x squared minus 7x plus 12 equals 0. So when we do that, we get x take 3 times x take 4 equals 0. So x is either 3 or 4. Next up, x squared minus 5x equals 0. So we pull out x. So we get x times x take 5 equals 0. And therefore x is either 0 or 5. Then x squared take 16 equals 0. So we do x add 4 times x take 4. So x is plus or minus 4. Then comes 2x squared add 5x take 3 equals 0. So we're going to do 2x minus 1 times x plus 3. So we get x is either a half or negative 3. Then comes 3x squared minus 10x plus 8 equals 0. So we're going to do 3x minus 2 all times x, no, we're going to do 3x plus 2 all times x minus 4. So, negative 2 over 3 or 4. Negative 2 over 3 or 4. Now we're going to try solving some quadratics by completing the square. So we have to write, we'll be completing the square later, but we have to write x squared add 6x add 1 in the form of x add a all squared add b. So we're going to half the b coefficient, or the linear coefficient. So we get x add 3 all squared. That creates a 9 out of nowhere, so we've got to actually subtract that away. So the final answer should be x add 3 all squared take 8. Then write x squared take 10x add 30 in the form x add a all squared add b. So that should be x all squared plus 5. Now state the minimum value of x squared add 8x add 3. Alright, so we're going to get in completed square form, in which case we get x add 4 all squared minus 13. X add 4 all squared minus 13. Now we have to make this as small as possible. So we're going to put what's inside the brackets equal to 0. And then we just get the minus 13 on the outside. And that's the answer, minus 13. So now write 2x squared add 12x add 5 in the form a all times x add b all squared plus c. So we're going to factor out 2. So we get 2 open brackets x squared add 6x add 5 over 2. Or we could leave the 5 on the outside. So 2 open brackets x add 3 all squared, 2 open brackets x add 3 all squared. We end up generating an 18 from that, so we actually have to subtract 13. So 2 open brackets x add 3 all squared take 13. And now we have to solve x squared take 4x take 1 equals 0 by completing the square and giving exact answers. So we're going to get x take 2 all squared, and then we have to, let's see, that generates a 4, but we have to get it down to minus 1, so we've actually got to take away 5, so we move that to the other side, so x take 2 all squared equals 5. Square root both sides, move the 2 over, so x is equal to 2 plus or minus root 5. Okay. Then comes the discriminant and nature of roots. So we need to find the discriminant of 2x squared take 5x add 1. The discriminant is b squared minus 4ac. So we need to do 20, should be 70 roots. State how many real roots x squared add 4x add 7 equals 0 has. We can apply the discriminant here. So we get 4 squared minus 4 times 1 times 7. So 16 minus 28. Which is negative 12, and because the discriminant is negative, it has no real roots. Find the values of k for which x squared at kx at 9 equals 0 has equal roots. Okay, so if we square x at 3, we get x squared at 6x at 9. And if we square x minus 3, we get x squared minus 6x minus 9 equals 0. Alright, so k is either positive or negative 6. Now find the value of k for which kx squared add 4x add 1 equals 0 has equal roots. Okay, so if we do 2x add 1 and we square that, we get 4x squared add 4x add 1. So the value of k here should just be 4. It should be 4. In fact, it would work if I actually squared negative. No, it actually wouldn't. Only 2. Only 2. Alright, so k is 4. Find the range of values of k for which x squared at 6x add k equals 0 has 2 distinct real roots. So we need to make sure that b squared minus 4ac is greater than 0. So let's see, 36 minus 4k has to be greater than 0. Okay. So 36 has to be greater than 4k. So 9 has to be greater than k, and that's the answer. Okay, now we're going to sketch quadratic graphs mentally. Okay. Okay, so state the x coordinates of the point where y is equal to x minus 2 times x at 5 crosses the x-axis. The answer is 2 and negative 5. State the y-intercept of y equals x squared minus 3x minus 10. That should be minus 10. State the coordinates of the vertex of y equals x take 3 all squared plus 4. So that should be 3, 4. State the equation of the line of symmetry of y equals x squared minus 6x at 5. So we're going to use x equals minus b over 2a, so it should be 6 over 2, which is 3. X equals 3. State the coordinates of the turning point of y equals negative x squared at 4x take 1. Okay, so we have to find the line of symmetry, which is minus 4 over minus 2, so that's 2. And then we sub in 2, so we get minus 4 plus 8 minus 1, so 3. So 2, 3. Right, now modeling with quadratics. A ball's height in meters after t seconds is h equals 20t minus 5t squared. Find the time it returns to the ground. So we factor out 5t, and then in the brackets we get 4 minus t. Okay, so 5t open brackets 4 minus t. So it should return at 4 seconds. For the same model, h equals 20t take 5t squared, find the maximum height reached. So it leaves at 0 seconds and it hits the ground at 4 seconds, so its maximum height is reached at 2 seconds, so we sub t equals 2, and we get 20 times 2, take away 5 times 2 squared, so that should be 40 take 20, so 20 meters. A rectangle has perimeter 20 centimeters, find its maximum possible area. Okay, so that will be when it's most square-like, so it'll be a 5 by 5 centimeter square, so its maximum possible area is 25 square centimeters. Two numbers have a sum of 12, find the greatest possible product. Alright, that'll be bang in the middle, so 36. 6 times 6 is 36. A firm's profit in pounds is P equals negative n squared plus 30n, take 50. Find the value of n giving maximum profit. Okay, so we need the line of symmetry, which is minus 30 over minus 2a. Okay, just hold on a second, is that right? Minus 30 over 2 times minus 1. So it should be 15. Should be 15. And we sub in 15. So we get negative 225 plus 450, which is 225. And then take 50 and we get 175. But the value of n that we're interested in is 15. All right. Okay, I would need to go in a minute. So just look at chapter 3. Okay, sequences and series. An arithmetic sequence has first term 5 and common difference 3. Find the 20th term. Alright, so we need to do 5 plus 19 times 3, so that would be 62. An arithmetic sequence has third term 11 and seventh term 27. Find the common difference. Okay, to get from the third term to the seventh term, I added on the common difference 4 times, and their gap is 16, so the common difference is 4. And the arithmetic sequence starts at 100 with common difference negative 7. Which term is the first negative one? Alright, so the first term is 100. If I take away, alright, the next term is 93. How do you do this? Alright, so my aim is to get to 9. Okay, if I get to 98, which term is the first negative one. I know it's either 14th or 15th, but I need to actually just see. If I do negative 7 once, that gives me down to 93. Twice, 86. Alright, so if I do it, yeah, 15 times I get negative. Alright, so it's 15. Is 61 a term of the sequence 4, 9, 14? Answer yes or no. No, it's not, because that's going up in fives. An arithmetic sequence has first term 2 and 10th term 29. Find the common difference. Alright, so I added on the common difference 9 times. The gap between them is 27, so the common difference is 3. Arithmetic series now. Find the sum of the first 20 terms of the arithmetic series, where the first term is 3 and the common difference is 4. Okay. How do you do these? You find the average of the first and last terms, and then you multiply by how many terms there actually are. Check if that works on the answer that you know. Add up the numbers from 1 to 100, that's 5050. I already know that. And yes, it works. No, wait. Oh, yep, that does actually work. Okay. First term is 3, common difference is 4, 20 terms. Alright, so 3 plus 19 times 4. 19 times 4 is 76, so 79. 79 at 3 is 82. 82 over 2 is 41, and 41 times 20 is 820. 820. Okay, find the sum of the first 50 positive integers. We're going to pair 1 with 50, 2 with 49, 3 with 48, and so on. So we get 25 pairs, each adding up to 51. So we need to do 25 times 51. All right, how do you do that? 25 times 51. 1,275. An arithmetic series has the first term being 7 and the common difference being negative 12, negative 2. Find, oh, wait. It's 10 past, so I have to